Hello everyone. So here we shall solve some more KCET previous year questions on the chapter Permutation and Combination. Uh, so in any of the solutions, if you are unable to understand any of the steps or any other doubts you are having, then please write that in the comments section. We shall clarify them in the subsequent videos. And if you feel that uh, in any of the chapters of maths you are feeling that it is more difficult, then also please write the name of that chapter in the comments section. Also the homeworks on every chapter will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here we shall solve the very first question. So here it has been told that the number of positive divisors of 252. So now here first we have to do the prime factorization of 252. Since first we need to find what are the prime factors and what are the exponents of those prime factors which are contained in 252. So we so it is divisible by 2. So 2 ones are 2, 2 twos are 4, 2 6 are 12. Then again with 2, 2 6 are 12, 2 3 are 6, and then it will go with 3. 3 2s are 6, 3 1s are 3. Then it will go with 3 again, 3 7s are 21. Therefore, 252 can be written as 2 power 2 into 3 power 2 into 7 power 1. So now, therefore, the rule is that if any composite number, suppose x, that can be written in the form of, suppose its prime factorization is p1 whole power alpha 1 into p2 whole power alpha 2 into p3 whole power alpha 3, where p1, p2, p3 are the prime factors of the number x, then the number of, so this rule we have to apply. So if the composite number x has the prime factors p1, p2 and p3, and their exponents are alpha 1, alpha 2 and alpha 3 respectively, then the number of positive divisors of x, the number of positive divisors of x is are given as, the number of positive divisors of x is given as alpha 1 plus 1 into alpha 2 plus 2 into alpha 3 plus 3. No, sorry, alpha 1 plus 1 into alpha 2 plus 1 into alpha 3 plus 1. So therefore here also the prime factors are 2, 3 and 7, and which are raised to the exponents 2, 2 and 1 respectively. So therefore here the number of positive divisors of 252 are, the number of positive divisors of 252 are 2 plus 1 into 3 plus 1 into 1 plus 1. Sorry, it is 2 plus 1 into 1 plus 1. So that is 3 into 3 into 2. So that is 9 to the 18. So option C is the correct answer. Then here it has been told that a simple graph contains 24 edges. A simple graph contains 24 edges. Then the number of and degree of each vertex is 3. Then the number of vertices is, so let the number of vertices of the graph, that is equal to n, and it is given that the degree, and that the degree of each vertex is 3. Then the sum of the degrees of the same then we can say, then the total degree of the simple graph, the total degree of the simple graph, it means that the total degree of all the vertices, of that simple graph will be equal to 3 into n, 3n. Since each vertex has degree 3 and the number of vertices is n. So now we know that the sum of all the degrees, the sum of the degrees of all the vertices, in the simple graph, that is equal to 2 into the number of edges in the simple graph. That is equal to 2 into the number of edges in the simple graph. So therefore the sum of the degrees of all the vertices, that is 3n, that will be equal to 2 into the number of edges, sum of the degrees of all the vertices, that is 3n. So that will be equal to 2 into the number of edges in the simple graph, which is given as 24. Therefore 3n, that is equal to 48. Sorry, the 3n, that is equal to 48. So n will be equal to, so n will be equal to 16. So the number of vertices is 16. So there are 16 vertices. So option C is the correct answer. Then here it is told the sum of all positive divisors of 242 except 1 and itself is. So first we need to find the prime factorization of 242 in order to find how many prime factors are there in 242. So 2 ones are 2, 2 twos are 4, 2 ones are 2, then it will go with 3 again. No, it will not go with 3, it will go with 11. So 11 11s are 121. So therefore 242 is written as 2 power 1 into 11 power 2. So now therefore the divisors, or I can say the positive divisors, all the positive divisors of 242 are, so we can take 2 power 0, 2 I can take power 0 to 1, and this 11 also I can take from power 0 to 2. So they are 2 power 0 into 11 power 0, that is 1, and 2 power 0 into 11 power 1, that is 11, 2 power 0 into 11 square, that is 121, and then 2 power 0 into 11, okay, then 2 power 1 into 11 power 0, that is 2, then 2 power 1 into 11 power 1, so that is 22, 2 power 1 into 11 square, that is 242. So these are the factors. So now we have to find the sum of all positive divisors of 242 except 1 and itself. So this 1 we should not take and 242 we should not take. Therefore the required sum of all the positive divisors of 242 except 1 and itself will be 11 plus 121 plus 2 plus 2. So this will be 2 plus 2 is 4, 4 plus 1, there is 5, 5 plus 1, there is 6, 6, then 2 plus 1, there is 3, so 136. positive divisors. Okay, 11, 121. Sorry, this will be 22, not 2. This is 22. So 11, 21, 22 plus 2. So 2 plus 2, 4, 4 plus 2, 6, and then 4 plus 1, 5, 156. This is 156. Okay, so option A is the correct answer. So in any of the steps of the solution, if you are unable to understand or any other doubts, if you have, then please write us in the comments section. Then here it is told that how many 5-digit telephone numbers can be constructed using how many 5-digit telephone numbers can be constructed using the digit 0 to 9 if each number starts with 67 and no digit appears more than once. So now it means that every number should start with 67 only, and it should be a 5-digit telephone number, 5-digit telephone number. So the remaining 3 digits should be filled from 0 to 9, 0 to 9 except 6 and 7. Since why 6 and 7 have been already used, and it is told that no digit appears more than once, it means that here no repetition is allowed actually, that there should be no repetition of the digits. So 67, then so out of these 10 digits, okay, so out of these 10 digits, 2 has been already used. So out of the remaining 8, we have to choose any 3. Each number starts with 67. Okay, 5-digit telephone number should be there. Okay, so out of the remaining 8, we have to choose any 3. We have to choose any 3, and then we have to rearrange these 3 also. So therefore the answer will be 8C3 into 3 factorial. Since why by 3 factorial we can arrange those 3 numbers also. So the answer will be 8 by 3 into 7 by 2 into 6 by 1 into, that is 3 into 2, that is 6. So 3 2s are 6. So 7 6 are 42. 42 into 8, that is 2 8s are 16. Then 4 is a 32. So that is 336. So option B is the correct answer. So 336 is the answer. 336 such 5-digit telephone numbers can be formed where there is no repetition, and it will start with 67. So here it is told that if NC12 that is equal to NC8, then N is equal to how much? So now the rule is that if NCX that is equal to NCY, then either X is equal to Y, or X plus Y, that should be equal to N. That should be equal to N. X plus Y should be equal to N. So now here, so therefore here 12 and 8, they are not same. So therefore N should be equal to 12 plus 8, that is 20. So N should be equal to 20. So option D is the correct answer. Then here it is told everybody in a room shakes hands with everybody else. The total number of handshakes is 45. Then the total number of persons in the room is. So when 2 persons will shake hands, then 1 handshake will be made. So for each handshake, so the rule is what, that for each handshake 2 persons are always involved. 2 persons are required. 2 persons are required for each handshake. So now therefore if there are n persons in a room, if there are n number of n number of persons in a room, then the total number of handshakes will be the total number of handshakes will be MC2. So since why out of these n persons we have to choose any two person in NC2 ways. So there will be NC2 handshakes. So NC2 is equal to 45. So then we have to find out n. So therefore I can NC2 means it is n by 2 into n minus 1, that is equal to 45. So I can say that n square minus n, that is equal to 90. So therefore n square minus n minus 90, that is equal to 0. And if we factorize it, then we will get n minus 10 into n plus 9, that is equal to 0. So now n cannot be negative, n can't be negative. So therefore n plus 9, that cannot be 0. So therefore n should be equal to 10. So n is equal to 10. So therefore option B is the correct answer. So it means there are 10 persons in the room. There are 10 persons in the room. Then the number of ways in which 5 girls and 3 boys can be seated in a row so that no 2 boys are together. So there are 5 girls. So here the first girl and the second girl and the third girl and the fourth girl and the fifth girl should be seated. Now 3 boys are there, 3 boys, B1, B2 and B3. Let's say they are numbered as B1, B2 and B3. Okay, so these 3 boys cannot are not sitting together. So it means that all the 3 boys should sit in between these girls only. So in between the girls there are 1, 2, 3, 4, 5, 6 places. So 6 options are there to sit. So 6 options are there to sit for the 3 boys. So out of these 6, now out of these 6 we shall choose any 3 places by 63 ways, and then those okay, so by 63 ways we can choose, we choose any 3 places, out of out of these 6 places where the boys can sit. Since why boys should sit in between the girls only. So it will be and those 3 boys can be arranged also in 3 factorial ways, and these 5 girls can also be arranged in 5 factorial ways. So therefore this is the total number, the required total number of ways in which they can be seated in a row, in which they can be seated in a row. Which they can be seated in a row. So 6C3, that will be 6 by 3 into 5 by 2 into 4 by 1 to 3 factorial, that is 3 into 2 to 5 factorial, that is 5 into 4 into 3 into 2. So this 3 2s are 6, then 5 4s are 20, 20 into this is 6 into 5 4s are 20 into 6, the 20 into 6, so 20 into 6, that is 120, 120 into 120. So 12 12s are 144, so it is 14,400. So option D is the correct answer. So then we shall solve the last question of this chapter. It is the number of 4-digit numbers whose repetition, the number of 4-digit numbers without repetition that can be formed using the digits 1, 2, 3, 4, 5, 6 till 7, in which each number has two odd digits and two even digits is. So 4-digit number should be formed. 4-digit number. 4-digit number should be formed, and there should be no repetition. There should be no repetition. There should be no repetition. Okay. 4-digit numbers without repetition. So in which each number has two odd digits and two even digits. So out of 1, 2, 3, 4, 5, 6, 7, 2, 4 and 6 are even numbers. So here we have 3 even numbers and 1, 3, 5 and 7. So 4 odd numbers. So out of these 4 odd numbers, I have to choose any two by 4C2 ways. And out, so 4C2 means it is the number of ways of selecting, the number of ways of selecting any two odd numbers. Any two odd numbers out of the 4 odd numbers. And two even digits also should be there. So by 3C2 ways I can choose this. So 3C2 is the number of ways of selecting any two even numbers out of these 3 even numbers and into 4 factorial. Since why these 4 digits can be arranged in 4 factorial ways. So 4 factorial is what? It is the number of ways of arranging all the 4 digits. Number of ways of arranging the 4 digits. So the answer will be 4C2, that is 4 by 2 into 3 by 1, and into 3C2 means it is 3C1 only, so that is 3 by 1, into 4 factorial means it is 4 into 3 into 2 into 1. So 2 2s are 4, 2 and 2 will cancel, and 4 3s are 12, 12 into 3 into 4 3s are 12. So 12 12s are 144, 144 into 3. So that is 3 4s are 12 and 3 4s are 12, that is 13, 3 1s are 3, that is 432. 432, so that is option A. So option A is the correct answer. So hope you have understood the solutions of all these questions, and if you have any more doubts in any of the steps of the solution, then please write in the comments section, and please install our Sapience education application, whose link has been provided in the description. Okay, so here we shall end our class. So thank you everyone. Bye.